subscribe to our YouTube channel. Click the bell icon for updates.
Hello and welcome to StratNewsGlobal and welcome to The Gist, our signature show on foreign policy, security, trade and technology. This evening, the spotlight is on 5G. I am Surya Gangadharan and I'd like to welcome our guest for this evening, Professor Bhaskar Ramamurthi, Director of IIT Madras. He's also closely involved in the 5G development process. Professor Ramamurthi, welcome. Glad to have you.
Thank you very much. Glad to be back on StratNewsGlobal.
First of all, we're going to take a quick look at an organization called TSDSI, which Professor Ramamurthi himself heads as chairman. It is the Telecom standards.
I was the previous chairman. Currently, somebody else is the chairman. My term got over.
So, Professor Ramamurthi was involved with TSDSI. It's basically the Telecom Standards Development Society of India, and it's been set up for with a number of objectives in mind. You can start seeing them right now. To basically develop standardized India-specific telecom equipment, take Indian standards to the world, help build and manufacturing standards in India, and of course help developing countries, which is an old Indian policy and endeavor. Let's now get to Professor Ramamurthi with our, okay, let's play the graphic first. Everybody take a quick look at it. Okay, Professor Ramamurthi, in simple terms, concise for a largely general audience, what is 5GI and how different is it from 5G?
Thank you, Mr. Gangadharan. So, you know, we have all of us have been familiar with the progress of telecom technology from 2G to 3G and 4G and so on.
Yeah.
From 3G onwards, the standards are very complicated. You need standards in telecom because equipment A has to talk to equipment B, or handset has to talk to the tower. If I have to talk to you, unless we agree on the English and how English is spoken and understood, we can't talk, right? So you need to fix many things, many protocols, and so there are standards. There's a lot of new ideas and innovations going into every generation. So there are a lot of IP in these standards. Once the IP gets into the standard, then everybody has to use it. Everybody has to license it. So that's basically how this thing is done. And there is an organization, global forum called 3GPP, obviously started when 3G was evolved, and it has continued on to develop 4G and now 5G. It's a forum of companies from all over the world where this next generation standard is continuously evolved. After 5G, it will evolve to 5G advanced, and then it will evolve to 6G and so on. And the global 5G, the 5G standard that has been finalized. Finally, of course, the standard gets ratified by countries at the ITU, but ITU doesn't really do any of the homework. It's too complicated to do. It's all done in these forums. 5G, we are also, TSDSI is also a partner organization in 3GPP, and we are also part of the 5G standard development. When in 2015, when 5G was the requirements for 5G were laid out by ITU. India piloted a new requirement for the first time, said that 5G must support what's called low mobility, large cell, rural coverage. In a very small nutshell, it means it must cover a large, across the country, large habitations, people moving around on normal vehicles, 2-wheelers, 3-wheelers, 4-wheelers, and so on, at not very high speed, and maybe many of them in their homes and in their fields, must cover over a large area. The cells are large, the towers have to cover a larger area and must provide 5G quality service. Till then, the only rural use case that was there in 4G and 3G and so on was a high-speed vehicle on highways as the use case. So this was approved by ITU, but with somewhat watered down requirements. The coverage area was reduced to about 3.5 kilometer radius. We could not, there were a lot of consensus building in ITU and so on, and we had to agree to that. But there's nothing that prevents you from developing a standard which outperforms the requirement. And India needs 6 kilometer coverage to cover all our villages from the BharatNet points of presence. So we were determined that we would develop the standard in such a way that it will give us 6 kilometer coverage. When we tried to do that at 3GPP, there was lack of consensus, and we were not able to get in the additional features that were necessary in the standard to get that coverage. So when 5G had to be, when we had an opportunity to submit a version of 5G to ITU from India. So what we did is when we adopted 5G in TSGSI, it's called transposition. We added to it some features that got us the rural coverage that we wanted, and we added it in such a way that it would be easy to ensure interoperability, meaning 5G handsets would work with 5Gi base stations, 5Gi base stations would work with 5G handsets. Of course, 5Gi handsets working with 5Gi base stations would be the only case where you would get the improved coverage. But in all other cases, it would work just like 5G. Okay? So this is called seamless interoperability, and we ensured that. And we took 5Gi to ITU, and ITU is a place where they'll approve anything that meets the requirement. So ITU said, finally, after a long process of evaluation and voting by countries and so on, ITU approved both 5G and 5Gi as standards that meet 5G requirements as laid out by, it's called IMT 2020 by them, not 5G, as laid out by ITU. Of course, we know that 5Gi exceeds 5G requirement, IMT 2020 requirements in the context of rural coverage. So just in a nutshell, 5Gi is a superset of 5G, interoperable with 5G, and does not add to the cost. The features that we added actually do not add to the cost of either the base station or the handset. And it provides India with what it needs additionally for its rural areas.
So there is a question here. Is there a difference between frequency of 5G and 5Gi?
No, absolutely the same. As I told you, the way we envision it, the handsets, smartphones will be made which support both 5G and 5Gi, 5G plus 5Gi. Towers, the equipment on the towers will support both 5G and 5Gi. Both will not cost anything more. The system will automatically work in any combination. If there's a 5G tower and you have a 5Gi handset, 5G plus 5Gi handset, it will just work in 5G mode. If you have a 5Gi tower, it will work with 5Gi mode, and you'll get the enhanced coverage. Otherwise, you won't get it. You will have absolutely you won't know anything about what is being used, and there's no difference to the user, neither in cost nor in performance.
Then why does telecom industry have so many reservations?
So I can only guess now, because when you say telecom industry, there are many parts of the industry. There are operators.
Yeah.
There are telecom service providers in India, and not all of them have reservations. Some have openly expressed support. There are telecom equipment providers. That is both on the network side, the towers as well as the handsets. The equipment provider, they're all very handful in number. You know that this is dominated by a few players. The telecom equipment providers, many of them have already, they've spent a good part of the last 2-3 years fine-tuning their 5G offering. They've just last 1 year, they've come out with their 5G equipment. Probably they do not want to rock the boat. They don't want to add the 5Gi features. We don't know. But some of them, many of them are, some of them are neutral. Some of them are saying they don't need 5Gi. 5Gi itself will do the job, etc., etc. Handset manufacturers are waiting to see whether 5Gi towers, base stations will be deployed. Then they will add what they have to add. We know from discussions with handset manufacturers, chipset manufacturers, that they agree that it's a fairly straightforward thing to do. It's just a question of whether to go through the trouble of doing it or not, when to do it. I think India signals very clearly that it wants 5Gi. I think all of this will happen very quickly.
Okay. So is 5Gi based on Open RAN? That's another question we have.
Yeah, Open RAN. So Open RAN is what is happening is that, I'll give you the example of the old PC. You can assemble a PC yourself, right? With hard disk, you can buy a hard disk, you can buy a CPU card, you can buy a monitor, and so on. So a PC is like Open RAN. You can buy the tower top equipment from somebody, you can buy the and so on. Generally, the vendors who supply these things, networks, don't like it. So there is a battle going on between whether to open it up or not, and how to prevent it, how to thwart the opening up and so on. Open RAN is a standard that says that the radio access network can be open, can be bought from anybody, can be mixed and matched and so on. It has nothing to do with 5G or 5GI. Both of them can be made compatible to Open RAN. Both of them can be made in a fashion that makes it difficult for you to use Open RAN. This is purely a business market related issue.
Mm-hmm. Will this add to the cost? Will 5GI add to the cost of the...
I mentioned this too, it will not. I'll be more specific. 5GI has only one major feature in the uplink. It's the uplink. Uplink refers to the direction of communication from handset to tower. It is the handset to tower direction that limits the coverage. And so we have done something there significant, which improves the coverage from the handset to the tower. So the tower equipment has to have an additional receiver mode, which happens to be in the tower equipment. Most of the stuff is implemented in programmable platforms. I'm not necessarily saying software. Programmable platforms could be programmable chips, but it's all usually implemented in programmable platforms. So adding one more receiver mode algorithm into the tower top equipment is usually not a problem. And we are ourselves implementing it. We know it's not a problem. So the tower top equipment, when you add an additional module in software programming, it doesn't add to the cost. Mm-hmm. There is a one-time cost in testing and so on. Sure, no doubt about it. On the phone side, you do have to make some modifications to the chip, but actually it turns out the amount of circuitry you have to add would probably not even show up in the area. Normally chip complexity is measured in terms of area. It won't even show, or in transistor count, it won't even show up. And they'll probably have to do it in the next. Chipsets are constantly revised every 6 months, every 9 months by the major vendors. The next version, whenever it's coming out, they'll have to add it. Again, they'll have to go through a testing cycle, but that's it. There is no additional cost. Finally, a 5G plus 5GI handset will cost no more than a 5G handset. And a 5G plus 5GI tower equipment will cost no more than a 5G tower.
Mm-hmm. So then, what is the issue really? Is it something about...
No, the issue is only of, as I told you, the equipment vendors, they're only, you can count them in less than the fingers of one hand. They are not inclined to, at least they'd rather not get into this. And there is also a move to try to, what we tried to do was actually whatever we wanted in 5GI, we tried to put it into the 5G itself, but it was not accepted. And so we had to do it this way. There's again a move to try to do that in the next version of 5G. If that happens, we are fine. We have told them that we are willing as long as the main features are kept intact. And that effort is also going on. Maybe they don't want to have to deal with this. It's a little messy in some sense. They don't want, that's possible. But I think finally India is such a big market. If we send a clear signal, I think everybody will deliver. I don't think there's a problem. There's no real problem.
Has this been conveyed to the telcos? I mean,
yes. We had many meetings. We recently had a stakeholders meeting where the Secretary of DOT was the chairman, and we was conveyed very clearly that three or four very important things were conveyed. One, that we are not asking for 5GI to be mandated in the country as the sole standard. The reason for that is very simple, though it would make sense. The reason is that 5GI equipment as on date is not available. So you don't want to hold up the country even for anything for even a few months. So, and there's no need to. Both 5G and 5G are approved by ITU. Both can, and we have already said both can coexist. The same network can operate both, and we don't see any need for mandating. The second thing we have said is there's no problem in interoperability. The third thing is there is no cost increase. So what we have made it very, the telcos are very clear now that. In fact, that the telcos have I see that there's questions about interoperability, about being caught with some islanded standard and so on. All those have gone away. Now the main opposition is coming from the vendors of this equipment. The latest article yesterday you might have seen was from the Association of Telecom Equipment Vendors of some major countries.
Yeah, I
think this is purely now a business issue. I mean, it appears to be. Some of them are talking about the quad and other things. I don't understand what it's got to do with the quad, but anyway.
Yeah, that's strange. Because what about countries like China and Russia? How do they do this? I mean, do they have something?
The Chinese companies are part of 3GPP. So Huawei and ZTE are part of 3GPP. And Russia actually has been out of the loop. Russia doesn't come to these meetings. Russia, as far as I know, doesn't make any equipment either. Russia, My understanding is Russians are not very strong in electronics. I may be wrong, but I don't see any Russian vendors of these equipment. I think probably the Russians now use Chinese equipment. I would presume so. I don't know. I don't know.
A question.
I've never seen a Russian vendor of cellular telecom network equipment anywhere in the. I've not heard of them, so I don't know.
So they're using imported stuff, is it?
I would think so. I think most electronics in Russia is imported, right? Less like in India. I don't think they make anything, as far as I know. And presumably now it's all Chinese. I would think so.
So we have a question from Sarkaz. He says, could you please ask about 5G N78 C band? This is rather technical. 5G N78 C band.
So, okay, I really don't know what I don't remember off the top of my head what N78 C band is, but it's one of the frequency bands in which 5G may have been approved. So what is this question about it?
He's just asking, thank you for this discussion. Could you please ask about 5G N78 C band?
So I don't know what his question is unless he's more specific about that band. I don't know what he's asking. Yeah.
Okay. Yeah, I think that's about. Going forward, when do you expect 5G to be implemented, or shall we just say 5G to be implemented?
5G, the trials have been approved now. Trials will roll out. I think the government is indicating that by early next year they'll finish the auctions. So if the trials are over and the auction is done, I think equipment is available. Phones are already coming with 5G in the Indian market. So I think it can be rolled out. I suspect the initial rollout will be in the cities where the operators are a little stuck with spectrum and so on. See, 5G has many aspects to it. I don't think we will see many of those important new things about 5G becoming a reality immediately in India. I think the very first low-hanging fruit that the telecom service providers will do with 5G is to just increase the bandwidth available to operators, subscribers in the cities where they have a huge congestion problem. And so they will just, give more capacity to subscribers in Delhi, Bombay. That's what initially it will happen. But there are other aspects to 5G which will come a little later. I think it has something called a very low latency channel. So you can actually do machine type operations. You can control robots, you can control machines and so on with very low latency. You must have noticed in this video conference and all that, if I wave my hand, it takes some time for you to see it. Here it will be almost negligible time. And so that's what will enable, remote operations and so on. So that will take a little more time to come. And then, not that it can't be done, it's just that the market has to be developed. And then there are other features that are very important. You can have network slices. You can have an organization which wants countrywide or area-wide service with a guaranteed level of performance can be given a certain slice of the network against payment. And so they will get a certain assured quality of service and so on. So there are aspects to this that are very, very new, which will all come in over time. But initially what people are going to just see is, zippier phones and zippier connections. That's all.
Okay. So I have a question from Prathamesh Dusane. How can millimeter wave transmitter receivers like those support more users, more speed and have less cost compared to usual transceivers?
So millimeter wave. So the one thing new about 5G is that it also has it's also defined for the millimeter wave band, which is 26 gigahertz, 28 gigahertz, and so on, 30 gigahertz. Hitherto never used except for military communications and radar and so on. So now what happens when you go to those bands is the good news is you get lots of bandwidth. So you can do gigabit per second and so on. Bad news is its propagation is very poor. Not only it's getting closer to light, so it doesn't diffract very well around buildings and so on. And what's worse, once it starts raining, raindrops are quite bad. They are comparable in size to the wavelength, and so you'll get a lot of loss. So basically, these are not to be thought of in the same way as your cell phone. You can't just walk around into buildings out of it and hope that connections will remain. However, these can be very useful for setting up very high-speed links from tower. If you want to put up a small cell inside a mall or inside an office, and you want to connect it to the tower, you don't have a fiber. You can actually use millimeter wave. not just for a point-to-point link, but you can actually connect several of these to the tower and actually dynamically assign bandwidth and so on. So it's not like you can also give it to, you connect cell phones with it, but I expect very limited usage. Maybe they will use it in stadiums and so on. If you want to have a lot of people sitting in a stadium to be able to see on their phones interactive football or cricket while they are watching the match, then you need a lot of bandwidth. And in a stadium, there's not much, no buildings coming in the way. You could probably use millimeter wave in those kind of applications directly to cell phones. But that'll take time to come. I don't think any phones are coming out now that are supporting millimeter wave, but it'll come.
So last question from, again, Sarkaz. It's a clarification on an earlier question. He wanted to ask the difference between current bands for 4G and 5G C-band.
So 4G has support only in 2.3, up to 2.5, 2.6 gigahertz. 5G has the main band for 5G in the lower frequency bands is 3.5 gigahertz, around 3.5 gigahertz, about 400 megahertz there. And then it has a millimeter wave around 26, 28. So these are two new bands that are specifically for 5G, where there's a lot of bandwidth available for each link. And so 4G had only 20 megahertz channels, 30 megahertz channels. 5G has minimum 100 megahertz channels, even at 3.5 gigahertz. And at 26 gigahertz, it has 400 megahertz channels. So you get a lot of data rate through that, which can then be shared by several users.
Okay. So completely to our last question, is there any potential radiation hazard with 5G implementation?
So coming to radiation hazards, I think this is an old question. We've been using wireless sets for the last 100 odd years or more. There is no final word on what it does to life forms. It has not been known to do anything yet. No evidence of that, except of course we know that microwave can cook. So thermal effects of radiation are well understood. So by and large, till now, the consensus in the world, and WHO believes the same, and is that the only effect of ionizing radiation radio waves is heating. And all the safety standards have been developed to make sure that there's not any significant heating of the human body. But people challenge that view, and you never know what we'll find in the future. But as of now, that is the accepted position. And from that point of view, there's no difference really between what happens when 5G or 4G. So there's no new danger or new phenomenon. But there are people who challenge this view that the only impact of microwave radiation is heating. And so that debate will go on.
Okay. Anyway, we're completely at the end of our time. Professor Ramamurthi, thank you very much for clarifying all these issues. They're out there in the public realm, and I'm glad we were able to get you in at short notice to kind of put a explainer on all these things that are up there. Thank you very much, and pleasure talking to you, sir. I'm sure this debate will, of course, continue. Thank you again. And for all of you out there who come forward with your questions and your comments, keep writing to us. Do follow us on our website, follow us on Instagram and other social media. Keep up the discussions on 5G. We'll bring you more as we go forward. Thank you very much. Goodbye.